Good morning. We're going to take a look at solving combined inequalities. And what is a combined inequality? Well, a combined inequality is when we're looking at a statement such as this. S is less than or equal to 4, or S is greater than 7. Another example of a combined inequality, we have negative 4 is less than or equal to M, which is less than or equal to 4. And so these are two different kinds of combined inequalities. Let's talk about what these different kinds are called. We have conjunctions, and a conjunction is a compound statement formed by joining two statements and the connector and. But what does that really mean? That means that for a conjunction, you need to have two statements made true in order for it to work. And what does that look like in terms of math? Well, this problem right here is a conjunction because M has to be greater than negative 4, but M also has to be less than 4. This is another example of a conjunction, as are some of this example here and this example here. A disjunction is a compound statement formed by joining two statements with the connector or. In other words, only one of the two statements must be true in order to satisfy this inequality. For example, in terms of math, we have S is less than or equal to 4, or S is greater than 7. So if either one of these conditions are met, we're happy. Other examples on this page of disjunctions. Anytime you see this or statement, it's going to tell you we have a disjunction. So let's take a look at some examples. So in this video, I'm going to do these 4 examples here. And then we'll take a look, or then a separate video will cover these. But I do want you to try these 3 problems before you watch the video. So I'm actually going to start with question 3. Then I'll go to question 4, and then I'll come back up to 1 and 2. So for question 3, we have the condition x is greater than negative 3, or x is less than or equal to negative 3. Okay, so let's start with this first part. X is greater than negative 3. Well, this greater than symbol, in this part here, can x be equal to negative 3? Well, no. X can only be greater than negative 3. So that means we're going to have to use an open dot. And maybe that will work. There we go. So we have an open dot, and we need to define negative 3, don't we? Now, number lines don't have to have 0 in the middle. Personally, I like to put the number that we're looking at, the focal point number, in the middle. So let's put negative 3 in the middle. Let's say this would then be 0. So I'm defining the scale as 1 unit for every of these little tick marks. And so x is greater than negative 3. We're going to take our open dot, because x cannot be equal to negative 3. Going to place it right on 3. And then we are looking for all the numbers that are greater than 3. So I'm going to take a big, thick horizontal line, and I'm going to place it directly on this number line. Oops, that's the wrong type of arrow. Which one did I pick? Let's pick this one. And oh, there we go. And we're going to put that right on top. So right now we have graphed x is greater than negative 3. But we could also have x less than or equal to negative 3. So in this case, so x could equal negative 3, we're going to take a closed dot, maybe, there we go. And it's going to go right on top of our open dot. And then x could also be all of the values less than negative 3. So let's take our arrow tool, and there we go. So we have now graphed this disjunction. As long as one of these two conditions are met, we're happy. Now, obviously, all numbers will meet these two conditions. Let's take a look at this conjunction because we have the word and. So both of these conditions must be met. So first, let's look at the x has to be less than -3. We're going to use our open dot. Let's again put it on -3. Just going to borrow these numbers for a minute. All right, and this is x has to be greater than -3, so that that's the same. Wait a second, this is the same condition we have here. So right now we're looking at this situation. I'm going to duplicate this. But wait a second. How can I have a number that is both greater than -3 while also being less than or equal to -3? That's not exactly possible, is it? So in this case, there are no numbers that will satisfy this. So in this case, we have no solution. Oh well. And in this case, we have all real numbers. Now, if I have to say all real numbers, that also means that it's possible that there are imaginary numbers, and we'll talk about that later. So now let's move on to number 1. For number 1, we have 2 is less than m plus 1, which is less than or equal to 4. So notice how we have two separate statements. First, we have the statement -2 is less than m plus 1. And then we have the second statement, which is saying that m plus 1 is less than or equal to 4. And we're going to treat these two examples differently. We're going to split them apart. And you'll see right here we've done just that. So let's go ahead and solve this. What are we going to do to both sides to get the m by itself? Well, we're just going to subtract 1, subtract 1, and we're left with -3 is less than m. I should have typed this. I'm sorry. All right. Let's go ahead and use our purple question here. And I'm going to treat this completely independently, like the blue question doesn't matter at all. And so what am I going to do again? Well, I'm going to add 1. And for those of you who remember quadratics, this is really similar to quadratics in that you add two, you could have up to 2 different answers, right? So we're left with m is less than or equal to 5. All right, so now let's deal with these two statements. M is less than, -3 is less than m. So this less than, so m cannot equal 3, which is going to require a open dot, there we go. And so since I have -3 and 5, oh boy, I'm going to put -3 way over here. All right. And so we need to have this to scale. So -3, 2, 1, 0, 1. So I'm going to label 0. 1, 2, 3, 4, 5. All right, so I've labeled my key points here, so we're good. All right, so then now let's take a look at this statement here. So we have m is less than or equal to 5. Well, since this could also be equal to, that's going to require us to use a closed dot. So I'm going to grab my closed dot, put it right on 5. And so now let's look at the directions of our arrows. 3 is less than m. So that means m has to be greater than 3. That would mean we'd be shading to this side of the line, towards the dot. But m is also less than or equal to 5, so which means this dot is going to be shading this way. So in other words, we are just ending up with connecting the two dots. And so the solution set will be not including -3, but all the numbers larger than -3 to 5, including 5. And if I were to write this as an answer, I would simply have -3 is less than m, which is less than or greater to 5. Now I know I left that blank because I'm going to borrow this thing over here. And I'm going to stick it right there. All right, there we go. So the complete answer for this problem is the number line as well as the conjunction that is written right here. So that's the final answer. One more example, we have a disjunction because we have the word or. And so let's go ahead and solve these two problems. All right, so let's subtract 1, and we get 5y. That's an odd, I'm having troubles with those symbols. Minus 5. Drawing with a mouse pad, not easy. Divide by 5, divide by 5. So I get y is less than, that's better, -1, because -5 divided by -5, or positive 5 is -1. Let's take a look at our second example, or second part. 4y is less than or equal to y plus 9. I'm recording, buddy. So let's go ahead. Can you shut the door? You gotta love quarantine video making.
How is
I'm making a video.
Oh, right now?
Yes. All right. So. So let's subtract y from both sides. Minus y, so we can get the y's on one side. So 4y minus y is 3y. Is greater than 9. And then if I divide both sides by 3, I will end up with y is greater than 3. All right, so let's take a look here. So we're going to be dealing with two open dots because neither of these can be equal. So let's define -1 as right here. And it doesn't matter which little mark I use for -1. So that makes this 0, 1, 2, and 3. All right. And so now we're going to need another open dot at 3. And now let's see which way we're going to have our little arrows going. And go to the arrow tool. I think it's this one. All right. Okay. All right. So y is less than -1. So that means everything less than -1 is going to be going to this side. All right. Y is greater than 3. That means all the numbers greater than 3 here. And so there we go. So we have successfully graphed this disjunction. Please go ahead and work on these 3 problems here, then check your answers.